everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patil College of Diploma Engineering and Technology, Bhinder. As in the last lecture, we have been started chapter number 1, that is Basics of Railway Engineering. We started with the modes of transportation, what is a transportation system, what is a rail, what is a rail gauge, and what are the zones of railway. Okay, so now from this today's lecture, we have to start with the rail joints. So, what is a rail joint? The meeting places or the continuity of the railway tracks. Okay, so to ensure the continuity of a railway track, rail joints are necessary. This connection of any two adjoining rails in correct position is called as a rail joint. So definition of rail joint is the meeting places of any two adjoining rails in a railway track is known as a rail joint. It is impossible to construct a track without rail joint because the rails are manufactured in such a length that it should be economical in every respect. Okay, so what is the requirement of standard rail joint? The first is a perfect rail joint should be as strong and steep as the rail section itself. Both the adjoining rails aimed at the joints should be remain true in a line laterally as well as vertically when the train passes over the joint. Okay, so it should provide enough expansion gaps in between two adjoining ends of the rail for expansion of rails due to the variation in a temperature. It should be elastic both the laterally and vertically. It should be not allow the rail ends to get battered in any case. Otherwise, rail crack the rail. It should facilitate easy removal and replacement of rails without disturbing the whole track. It should be economical in its cost of construction as well as maintenance. These are the requirements. Now we start the types of rail joint. First is supported rail joint. When the rail's ends rest on single sleeper called as a joint sleeper and its term as a supported joint. Such a rail joints were the first constructed by placing three wooden sleepers abutting against each other under the opposite rail joints. Suspended rail joints when the rail's ends are projected beyond sleeper called as a shoulder sleeper and the joint is termed as a suspended rail joint. This type of a joint is generally used with the timber and steel through sleeper on Indian and foreign railways. Next is breech joint. When the rail ends are projected behind the sleeper as in the case of the suspended joint and they are connected by flat or corrugated plate called as this plate is called as breech plate and its term is called as breech joint. This type of a joints are not used on the Indian railway. Welded joint. These are the base joints as they fulfill nearly all the requirements of the ideal or perfect joints. The rail joints in which both the adjoining ends of the rails are welded together by a suitable type of welding are termed as a welded rail joint. Next is staggered or broken joint. The joints on railway track are not directly opposite to the joints of the rail track. When the joints in one rail is exactly opposite parallel rail length is known as a staggered joints. These are generally provided on curves where the length of the outer curve track is greater than length of inner curve track. Next is square or even joint. The joints of the one railway tracks are directly opposite to the joints of the other rail track. This type is generally used on straight track. Compromise joints where two different rail sections are provided to be jointed together, and it is done by means of fish plates which fit both the rails, and this is joints termed as a compromise joint. Last type of rail joint is insulated joint. When the insulating medium is inserted in the rail joint to stop the flow of current beyond the track circuit part, it is called as an insulated joint. It is used in a track beyond the station yard limits on either side of railway station. Next important topic is creep of rail. What is a creep? Creep is defined as the longitudinal movement of rail with respect to sleeper in a track. So what is the definition of creep of rail? The longitudinal movement of rail in a track is known as a creep of rail. It occurs in almost all the railway tracks but varies in a magnitude considerably. In some locations, the creeps may be several centimeters in a month, while in the other location, it may be negligible in that period. It is observed that rails have a tendency to move gradually in the interactional traffic. Now, the causes of creep of rail. First cause is wave action and wave theory. Next is accelerating or starting of train. Next is deaccelerating or stopping train. Next is percussion theory. Next is expansion and contraction of rail due to variation in a temperature. Next is intensity of traffic. Next is alignment of track. And last is gradient of track. This is the causes of creep. Effects of creep of rail. Sleepers move out of the position affecting the gauge and align. The rail joints are jammed and prevent expansion. Operation of switch becomes difficult. The surface track is disturbed, result in uncomfortable riding. Points and crossing gets distorted and become very difficult to keep them to correct gauge and alignment. Okay, so it is also become difficult to operate the switches. These are the effects of the creep. Now we start the causes of creep. First cause is wave action or wave theory. Wave motion is set up in resilient track by the moving wheel loads. The train wheels causes depression under themselves, forming a lift or crest immediately at the rear and front of the wheel. With the movement of wheels, the lifts on front of the moving wheels are carried forward, whereas the lifts at the rear of the moving wheels get back to their normal position. Creep is causes and creep causes. Thus, the rail are pushed forward, which causes a creep in forward direction. This is a wave theory. This is a diagram of wave motion theory for development of creep. Second is percussion theory. The rail creep is due to the impact of wheel at the end of facing rail at each fish plate joint. As shown in the figure, this is a fish plate. So, when the wheel is passed over such a rail joint, the trailing rail, this is a trailing rail, depress down and the wheel give the impact to the end of the facing rail, which result creep in forward direction. So, here is a trailing rail, this is your facing rail and this is your fish plate. So, when the wheel is passes over such a rail joint, the trailing rail is depressed down and will give the impact to the end of facing rail, and which is result in a creep. This creep is very small in a single impact, but cumulative effect of the number of wheels in quick succession result in sufficient creep. Next is accelerating or starting of train. At the time of accelerating or starting of a train, the engine will give a backward thrust which tends to push the rail backward, causing creep in a backward direction. Next is deaccelerating or stopping the train. When the train is deaccelerated or stopped, the braking effect tends to push the rail forward, thus causing the creep in the forward direction. Next is expansion and contraction of rails due to the variation in temperature. Creep may also be caused due to the unequal expansion, contraction of rails due to variation in a temperature. The creep in this case influenced by the range in a temperature variation and location of track. Next is intensity of traffic. In a single line track, the creep will be resulted in the direction of heavy intensity of traffic. It means in a single line system, if heavy equal traffic runs in the both direction, the creep is balanced. Otherwise, heavy traffic in one direction causes creep. In double line track, the creep occurs in both the tracks in the direction of the movement of trains. And the double line system, trains on a particular line being unidirectional, creep occurs in both the lines. Okay, so next is alignment of track. Creep is greater on the curved portion than on straight portion of the track. Gradient of the track. Creep is more on a track with a steep gradient, particularly if the trains move downward with the heavy loads. Prevention of creep. The following are the measures which are commonly adopted to prevent the creep. First is pulling back the rail. When the creep is directly visible or clearly visible, the best remedy is to pull the rail back to their original position by means of the crowbars and hooks through the fish holes. Okay. Next is provide a sufficient ballast and packing with care. Next prevention is use the steel sleeper. Steel throw sleepers are best. Increase in a number of sleeper can help. Using anchors and anti-creepers. 4 anchors per rails if creep is 7.5 cm to 15 cm per month. 6 anchors per rails if the creep is 22.5 to 25 cm per month. Used at a level crossing in yards and places of heavy brake application. By providing good quality of ballast in sufficient quantity, by proper maintenance of rail joints, these are the prevention of creeps. Okay? So, here is the end of the today's lecture. Thank you.